right, hello everybody. Let's start by reviewing some things that we did in previous classes. Describe in words the transformation of the quadratic I have below in words. So first thing we want to do is look for a reflection. Since there's a plus out here, there is no reflection. The next thing we want to know, is there a stretch or a compression? Since 9 is bigger than 1, there is a stretch of factor 3. Because we see the parentheses, we do have a horizontal translation of 7 units. And as we can remember, inside the parentheses, it's opposite of what we see here. So instead of minus, it's plus. It's going to be 7 units to the right. And since there are no numbers on the outside here, there is no vertical translation. So you want to mention all 4 each time. Kind of going the other way, we have transformations in words. We want to write a function. You have f of x. You could use y. Opens down means the function is negative. It has a compression factor of 1/3. So 1/3 fills in where that a is. Moves 3 units to the right, so it's horizontal. That puts up our parentheses. The square is always on the outside. It's going to be x minus 3. Normally to the right is plus, but inside the parentheses, it's opposite. And 2 units down. All right, we want to describe the characteristics of this quadratic. It is in vertex form. Does it open up or down? Because of this negative, it means that it is opening down. The vertex comes from the h and the k. In this case, the k is a +0. And the signs are always opposite inside the parentheses. So the vertex will be 5, 0. The axis of symmetry comes from our x value or our h value, and it's always in the form of x equals. Because this guy is facing down, the vertex is on top up here, making it a max. And the maximum value is always the y coordinate of that vertex, so it's a max at 0. To find the y-intercept, we substitute in 0 anywhere we see an x. It's going to be -5 squared minus 3 times 25. So we are going to get here minus 75. Y-intercept would be 0, -75. It is kind of implied when you talk about intercepts with the other one 0, but we should be writing it in this form. Domain is always all real numbers for all parabola. And the range is from the maximum point, and since it's going down, it's going to be y is less than or equal to 0. Okay, so now we're going to talk about characteristics of quads in a standard form, which is ax squared plus bx plus c, where the a, the b, and the c are numbers. The first thing we're going to do is just identify what a, b, and c are in our equation. In this equation, the a is in front of the x squared, so it's 3. B is in front of the x. You always want to take the sign in with it that's sitting in front, so this would be a -7. And our c is a constant, 2. For this function here, our a value, again, you take the sign in with it, would be -1/2. It's missing the bx term, so that makes b 0. The only thing to make that x go away is that 0, and our c is equal to +9. All right, so same thing as before. Our quads are either going to open down or open up. It will open down if a is negative. It will open up if a is positive. So I look at this equation here. I'm going to work with these same 2 equations through all the characteristics. Since the 3 is positive, for this parabola, it's going to open up. And for this one, the a is negative, so it's going to open down. Okay. We need to find the axis of symmetry. It's not as easy as it is in the other format of the vertex form. We do need to use this formula of x is equal to minus b over 2a. And that is going to go ahead and get us the axis of symmetry. Here's an example. Here was the equation telling us a is 1, b is 12, c is 32. Applying the formula minus b over 2a, we find that x is equal to 6, and that's creating the axis of symmetry. All right, so let's try this one here. X is equal to minus b, so it's going to be minus negative 12 over 2 times 3. A negative times a negative is a positive, so this winds up being 12 over 6. And x is equal to 2. So there's the equation for our axis of symmetry. For this one, it's going to be minus b, but our b in this case happens to be 0 because we're missing that x term, over 2 times negative 4, which just winds up being 0 over negative 8. So x is equal to 0. All right, the next thing we're going to want to find is the vertex. And we're going to find our vertex by plugging the x values that we just found into the equation to solve for y. So before we found our axis of symmetry for this equation to be 2, substitute in the 2, and then we evaluate. This is going to be 3 times 4 minus 24 minus 1. 12 minus 24 minus 1. And when you put all that together, you get negative 13. So this becomes the y value. So our vertex is going to be 2 from the axis of symmetry, and then the y value associated with it, minus 13. Let's try that one again, except with our other equation. We had found the axis of symmetry to be 0. So we need to figure out what y is when that x is 0. This one winds up being a real easy calculation because it's just negative 4 times 0 minus 7. So y here winds up being negative 7. Our x-coordinate comes from the axis of symmetry, and our y-coordinate comes from substituting that into the equation to solve for y. That's how we find our vertex. Max and min is the y from the vertex, just like it was in the other format. We have a minimum, again, if the parabola opens up because the vertex is on the bottom. And a maximum if it opens down because then the vertex is on the top. We found the vertex earlier for the first equation to be negative 13. Since it is opening upward, it is going to be y is greater than or equal to, no, I take that back. I was answering the range. It's going to, the way we're going to write this out is we're going to have a minimum at the y value, negative 13. Since the other equation was opening down, we're going to have a maximum at negative 7. Okay, y-intercept happens when you plug 0 in for x, but let's see what happens with both of these. See if you notice a pattern. Anything times 0 is 0. So all these cancel out, and we just left with y is equal to negative 1. Let's, over here, we get 0 squared. So we get y is equal to negative 7. If you're going to plug 0 into the standard form, these first two terms will drop each time. So the shortcut is that the y-intercept is always equal to the c value. So you don't even have to do this calculation. You can just look at these equations and go, yep, there's your y-intercept. There's your y-intercept. Last thing we're going to cover is domain and range. Domain is possible x values for Parabolas, it's always all real numbers. So the domain here will be all real numbers. The possible y values. So we had said that this guy was opening up, and we're 2, -13. So the range, and can you just use r, is y is greater than or equal to -13. Over here, domain, again, all real numbers. Since this guy was opening downward, all the y values are below. So range is going to be y is less than or equal to -7. All right, we're going to do 2 together. The rest will be tried on your own. I do have the keys listed in Schoology, but just kind of follow along the pattern that we need to work with here. Does this open up or down? Since the A is a plus, it opens up. To find the axis of symmetry, we want to use x is equal to minus b over 2a. So the b value in this case is -8. So x is equal to -8 all over 2 times 1. 2 negatives become a plus. We get 4, oops, we get 8. 8 over 2, which is 4. So I know our axis of symmetry is x is equal to 4. Your vertex will come from plugging this x value into this original equation. So y is going to equal 4 squared minus 8 times 4 plus 12. That's going to get you 16 minus 32 plus 12, which winds up being y is equal to -6. So our vertex comes from the x value of the axis of symmetry and the y value that we found by plugging it in. Because we know it's opening up, it's a minimum value, right? Because if they're opening up, your vertex is on the bottom. And it happens at this y value. So it's a minimum at -6. The y-intercepts are easy to find here. It's always just the constant, the c value. So remember, this is just your c value. So that's going to be the 0.012. Domain is always all real numbers. And the range is going to be from the y value heading up. So since we're heading up, it's y greater than or equal to, and -6, part of that vertex. All right, let's do one more together. We want to know if this function's opening up or down. It is opening down due to the negative. Axis of symmetry, again, comes from the formula x is equal to minus b over 2a. So we put minus, the b value is 2, over 2 times the a value, which is -1. And that's going to get us a +1. So x is equal to 1. There's your axis of symmetry. To find the vertex, we're going to plug 1 back into this original equation. So y, or f of x, is going to be minus 1 squared plus 2 times 1 plus 1 minus 1 plus 2 plus 1. And we get, let's see, what do we get here? These guys are going to cancel out. So we're going to get y is going to equal 2. Oh, no. -1 squared is 1. So when we put this in here, we should get 1, 2, 4. All right, so our vertex is going to be 1, 4. Because this is opening down, our vertex is on top, making it a min value at 4. Your y-intercept is just going to be what this guy is here. So the y-intercept, when x is 0, y will be 1. Domain, all real numbers. And the range comes from the y value heading down of the vertex. y is less than or equal to 4. All right, so the other problems we're going to try on your own. You can use the key. As always, if you have any questions at all, just let me know. Happy to help.